Hello everyone, I'm Karol Gaida, technical lead at Samurais, and today I will talk about creating games for iOS in Unreal Engine. During my career I spent some time working on multiplayer projects, but for about a year now I work also for a mobile game, on a mobile game Sword of Glory as a side project. You can see it here. I'm responsible for porting this game from Android to iOS. So developing an iOS game in Unreal Engine is possible but can be tricky. So in this presentation I won't give you solutions to the problems I encountered during my work, so you can save time and frustration. I assume we all have a basic knowledge of building iOS games, so I will skip the step-by-step tutorial and focus on issues. All my solutions should work both on Unreal Engine 4 and 5, and they are related to project development on Windows. So, if issue 1, permission denied, as we all know, when developing an iOS game we need a certificate and provision. So if we can't see the certificates page, or we cannot create new certificates on the Apple Developer Portal, we probably don't have permission for doing that. So we need to contact our IT guy for help, otherwise we can't do much. For me, the lack of access was the biggest struggle when I started porting my first game to iOS. Second, after creating the certificate in development portal, we need to generate also the private key on Mac. Make sure to do that on the Mac administrator account. It will save you some trouble later. We need to unlock the system keychain and upload the .cer file. The private key should be generated automatically, and it will be connected to the certificate that we uploaded to the keychain. So now we just need to export the private key as .p12 file and upload it to our Unreal project on Windows. Number 3, this issue is related to my specific project, but it's quite interesting, so I wanted to talk about it as well. When I opened the editor on a fresh project, I was welcomed by this error. It was caused by the preview rendering level set to Android by the previous developer. I didn't set up my environment for Android development, so when I opened the editor, it crashed at startup. But the fix is very easy though. We just need to locate the editor per project's user settings, and we need to change the preview feature level and preview shaded format name to the default states. So this is the equivalent of changing the preview rendering level inside the editor. Number 4, when we go to the iOS settings, we could see that the provision file has status identifier not matched. This is because the bundle identifier has not been filled in yet, or it just doesn't match the ID that we saved in the provision file in the Apple Developer Portal. So we need to go there and make sure that inside Unreal we have the same ID that we see here. So when everything is set up correctly, Unreal highlights in green the certificate and provision that is going to be used in the packaging process. In my case, it looks like this. So next, when we try to package the game for iOS and Unreal opens a page in documentation, or we see errors like this, it means the certificate and provision are not set up correctly, or Unreal cannot find them. It may be also caused by missing iTunes, so make sure to install it on your PC. Also make sure to download the iTunes from the Apple website directly instead of Windows Store, as the Apple version is always up to date. The errors may also pop up when we try to build for distribution, but we didn't import the distribution certificate to the Unreal project. So remember, if you build for distribution, always use the distribution certificate, and if you build for development, always use development certificate. Issue 6. If we are building a C++ project, we will most likely see the following error: keyset does not exist. It occurs when Unreal tries to code sign the packaged game and is unable to do so. This is a somewhat general error, and it may appear in several different situations. So the first thing, we should make sure that Unreal can connect to our Mac for remote code compiling via SSH. If the remote build options are not set up, do so. If the options are set up, make sure the connection works, in example by pinging your Mac via IP. If the connection works and you still see this error, open the Unreal editor as an administrator. It solved the issue in my case. Issue 7. When we try to install the packaged game on iPhone through the iPhone packager, and we see error about connecting to IPC port, it means that we don't have iTunes installed on our PC. Also, when the iPhone is constantly reconnecting to your PC, try to plug it to the rear USB connector. It may help. Otherwise, I would try a different USB cable. So when the game is installed successfully, we can see that in the iPhone packager log. Next, as we probably all know, the first thing we see when we launch our game for the first time on mobile is probably a crash. So let's check how to extract the crash dump. For accessing Unreal logs on iPhone, we can use iPhone packager. Just go to the advanced tools, other development tools, backup documents, and select the packaged game that was installed on the device. The packager will save the logs to the iOS backups folder. It will be located in your project directory or next to the iPhone packager exe, depending on whatever we selected the uproject file for the iPhone packager or not. In some cases, though, crash logs may not be included in the iOS backup folder. So what we could do is to try to find them in the iOS system crash dumps. So when we go to the Systems, Privacy, Analytics and Improvement, Analytics Data, we can find a list of files with analytic data collected by iOS. We can find a file named by our game title, and inside that file we can see the system dump log describing our crash. Unfortunately, this doesn't give us much because all functions are saved as memory addresses. So to find out what was called, we need to convert them into human-readable strings. So we need to symbolicate that crash. The easiest way to do so is through Xcode, but we need to connect our device directly to the Mac. I didn't have physical access to the Mac computer because I worked mostly remotely. So in my case, I use the symbolicate crash tool provided by the Xcode. So we can look for this tool inside the application directory. We will find several versions of it, but I use the one saved in Xcode shared frameworks. So now we need to extract the crash from our device, upload it to Mac, and then use the symbolicate crash tool to process the crash like this. As a result, we have a file in which the memory addresses are converted into actual functions names. So as you can see here, the crash was forced by my function. Be advised though, that this approach works only if we are symbolicating the crash on the same Mac that we used for the packaging the game, and we enable the dsym file generation in the project settings. What's more, the symbolicate crash tool has been deprecated in Xcode 13.3, and it will be removed in the future. So for other ways to symbolicate the crash, please see the Apple documentation. Number 9. When we finally get our game up and running, we may notice that it just looks bad on iPhone. This is because Unreal uses default graphics settings that may be not suited to our device, and we can change that through device profiles. By default, it provides a basic set of devices, so if our device is not on the list, we need to enable the device profile selector plugin. In my case, it is iOS device profile selector. The settings that are worth checking are mobile content scale factor and SG quality. The first one allows us to scale the scale resolution of our game to fit best the device screen resolution. Most of the time we will be using the value of 2 for iOS, which is the native resolution on iPhone. The scalability settings allows us to change the specific graphic settings. So for example, VFX, foliage, shadow or texture quality. All default values saved in device profiles should be good enough, but of course feel free to change them as you wish and see what happens. Just make sure to save your work by clicking Save as Default button. It will save you changes to the config file. It seemed obvious, but it took me some time to figure it out why my changes are making no effect on the device. If we are not satisfied with the results produced by the device profiles, there is another trick we could use, texture compression. Basically, we can tell the UI cooker that how much we want to compress the original textures for mobile. So for my UE4 project, I changed the PVRTC compression quality from 1 to 2, which caused better overall quality on mobile, but at the same time, it doubled the size of packaged game. PVRTC is the default texture compression format for iOS devices, but starting with the iPhone 6, Apple also supports ASTC. That's probably why the PVRTC is removed in the UE5. Also, Apple's GPU is based on ARM architecture, so make sure to select the ARM texture compressor. Number 10, this error. Shortly, if a build is not packaged for distribution, don't try to upload it to test flight. This error is the error that Transporter app will give us if we try to upload the development game. The error message states that we need to use the distribution provision profile to package the game, and to do that we need to tell the Unreal that we want to package for distribution. And we can do that in the project settings. Checking this will automatically change the build configuration from shipping to development, but we can set it back to development and still upload the game to test flight. In-app purchases don't work. First of all, if we want to use EIPs in our game, we need to enable that capability for our app ID in the Apple developer account, and of course refresh and download the provision file. Second, we need to fill the tax and banking information on the App Store Connect. It is usually handled by the account owner. Third, we need to add the actual EIPs in the App Store Connect. But please be aware that if you add a new or change the existing EIP, it may take 5 to 15 minutes before the change will be visible to your game. Next, we need to enable all these plugins related to online subsystem. And if we have a C++ project, we need to enable the online subsystem iOS for the iOS platform in the build.cs file. Then we need to add the iOS engine config file, and inside this file we need to enable the in-app purchases and disable the second version of App Store API if we are not using it. In my case, the second version doesn't work at all, and I have to disable it completely to make the purchases work. After all of that, we can go to the blueprint graph and start using the EIPs function. Just make sure to use version 1 of them without the v2 suffix if you are disabled the second version of the App Store API. Issue 12, pay to test. To test EIPs, we need a sandbox account, and that account allows us to buy items in-game without paying for them real money. But it could be quite interesting for developers to pay for testing their game. Even though the EIPs are connected to our game through App Store, we can actually test them in a locally installed build. We just need to make sure that we are logged into our App Store sandbox account on the device. Cloud saving doesn't work. To enable cloud saving in our game, we need to enable iCloud support in the capabilities list, and we also need to configure iCloud container for our game. Clicking on the configure button allows us to select from the container list, and the new container for our app ID should be automatically generated. Second, we need to enable CloudKit support in the project settings. We can also choose the synchronization strategy, so never basically disables the cloud synchronization, so that's not what we want. At the game start only, downloads the cloud data at the game startup, and always download the cloud data at the game startup, and every time the save game and load game functions are executed during the gameplay. Then we need to enable the online framework plugin. And lastly, we need to make sure that we are logged to our Apple account on the device and have the iCloud Drive enabled. We should also have iCloud enabled for our game. At this point, the cloud save should work properly. We can test that by playing our game up to the save point, reinstalling it, and launching again. The game should start at the last saved checkpoint. In case cloud saving still doesn't work, after all this setup, we can see what happens in the iCloud dashboard. So in the logs section, select the iCloud storage ID, select the development environment, and click search logs. If there are no logs there, the game probably didn't communicate with the cloud, so that may be an issue with the setup. So I recommend going through the setup process again. If in any chance we cannot select the iCloud storage, it could be because the problem with the storage. So I would go back to the Apple developer portal and generate the storage again. If the logs are there, but the cloud save still doesn't work, it may be due to the issue with the access to the file in the database. So let's go to the database, select the iCloud storage again, select the private database, and try to select file as a record type. If it doesn't exist, iCloud probably can't find the file in the database. So here we could try to force the database to create a new record for the file. Just click on the plus sign next to the records, select private database, select type file, and upload your sample save game from your PC. Now we could try to query records again, and we should see a record name save slot there. Last thing, if we want to test the cloud save through test flight, we need to deploy schema changes to production, and successful deployment is indicated by the green dot under the iCloud storage ID. Lost progress. There is a situation when we play the game offline and make some progress, then switch the internet back on. Unreal synchronizes with the iCloud at the game startup, causing the local save to be overridden, and that may lead to loss of progress. To solve this issue, I implement a custom solution for resolving the conflicting saves, which basically gives the player the opportunity to choose which save he wants to load. My first approach was to dynamically disable the CloudKit support. I wanted to stop the cloud synchronization for a while, load the local save, and then enable the synchronization again, and allow the game to download the data from the cloud. I implemented that by accessing the gconfig global variable and modifying the enable CloudKit support. This was a good try, but in the end it doesn't work because the online subsystem iOS is initialized at the game startup, and changing the config variable makes no effect in runtime. So next thing I thought about, what if I change the variable in the config and then reinitialize the online subsystem? I tried to do that, but unfortunately it resulted in a crash in a voice interface stick. I guess it's tightly connected with the online subsystem. I tried to disable all plugins related to voice, but it didn't solve the issue. So after that, I started digging into the online subsystem iOS to find out how the cloud synchronization worked. And I looked into the F-Online subsystem iOS, which performs this subsystem initialization. F-Online user cloud interface iOS, which defines the actual interface between Unreal Engine and iCloud. We can see a lot of Objective-C code there. And FIOS save game system, which overrides the default save game system function for saving and loading the game. We can go all the way up from this class to the uGameplay statics, which defines the async load game from slot and async save game to slot that we use in blueprints. I learned that when saving, Unreal first sends data to iCloud and then writes it to the local file. So I decided to modify the engine code and add my own function to save the game on the device. I just copied the other function and removed the call to the delegate. With that, I can distinguish between the local and cloud save by saving to two different slots. I used the first one for the local save only. So now I have two parallel save, and one of them is never synchronized with the cloud directly. Also, I added a timestamp to my save object to compare the local and cloud save. And when the timestamp in both saves are out of sync, I let the player choose which one he wants to load. And that's basically it. I hope these solutions will help you in your game development. Thank you for your time. Do you have any questions? Slides are available here.
Hi. Thanks for a great talk. I mostly worked with Unity and only recently switched to Unreal, and wanted to ask how hard it is to keep the project running on both Android and iOS at the same time. Do you have to have separate projects, or you have the one and you just run different builds from it?
We have separate project, and I recommend to have separate project because if you try to build everything in the one project, in one let's say repo, well, you can have different branches, but I don't think it's a good idea to have everything installed in one place. So yeah, we are working in a team of 2 people, and one guy is responsible for Android, second one for iOS, so there's no problem here, and so I recommend to split the.
Thank you.
Okay, so if there are no further questions, thank you for your time.